Hello programmers, this is Matt Karinga and this is week 4 of our Intro to Programming with Python, Maps, and Data Science. So in this week's lab, I'm going to do a case study of US cities, but I've added some more information to our data set that includes demographics, racial, ethnic categories, median income, poverty level, and included the 5-year population change that we've already started looking at. So we're really not going to do too much new in terms of breadth this week in computer programming, but we're going to add a lot more depth. And we're going to continue working with functions, with pandas and geopandas and making maps. And we're going to add this idea of color and using color maps to visually present our quantitative data. So the first block is the import statement. Now this very first line, this actually installs a library into our Python environment. And for some reason, map classify isn't included with Google Colab. So just install it the first time we run. And then these are the libraries we're going to be using today. Although I don't think we need HTML, and display is built in, but that's all right. I'll leave them here for now. I'll go through them. Pandas is our general data science library. Geopandas is the extension that allows us to map the pandas data. IPython display, especially this markdown function, which I'm aliasing as MD, lets us use markdown, markup language, and it's one of the things I'm going to go over, to put formatted text and embed our own data inside of it, right? So we can write instructions. This XYZ providers, these are the different tile layers for our maps we started looking at last week, like the dark maps, the different like geological surveys and things. Folium is the mapping service provider that geopandas uses, so we're going to use Folium directly to create some maps and things. And then I'm adding a couple new libraries. This is matplotlib, and it's the charting and plotting library that kind of works in conjunction with pandas. And we're going to focus on using color maps. So the idea with a color map is that it maps a set of data to a range of colors so that each data point has a color that represents it. So we're going to look at 3 kinds of color maps today, and we'll talk more about that as we go. Our next block should be very familiar to you guys by now. We have a data URL. This is a new data file. It's a geodata file. I know that because it's called .geojson, so it's not a CSV. And all of our geodata files have a geometry. So the geometry is what allows it to be placed on a map. All right. I'm calling the variable cities. I'm using geopandas to read the file off the internet. And then head, I'm just getting the first few rows of this data, right? So we've got the city, the state, total population, median income, and then these are the different ethnic breaks that we have, poverty, and then the calculated columns are population change and income change, so we can see if a city lost or gained wealth. The area, so we can calculate density or the size of the city, and then the point geometry, which places it on the map. I'm just going to note, looking through this data, some of our points, and this is from the census, what the census determined was the midpoint of the city. Some of them are a little bit strange, and I might try to merge a different geo file in as we move forward, but we're just going to work with the points where they are next week. In particular, San Francisco is placed out in the Bay, and the center of New York City is placed in Brooklyn, whereas normally we think of it as Manhattan. So a couple of those might come up when you're looking at the data. So this data set we're looking at is actually combining 3 different data sets from the census, from the American Community Survey. One is the 2022 ACS that has the ethnic breaks. One is the 2017 that we use to calculate the 5-year change in population and income. And then one are the tiger shape files, the geo files from 2018. So last week we learned to write our own functions, and I just wrote up like a little guide to using functions. And let me click in here though. You see how this appears inside? It's just plain text. I'm going to zoom out a little bit for now. I'll zoom back in when we start looking at the code. So this is called Markdown, and it's not a programming language, it's a markup language. So it just lets us take a plain text file and add some markup, some special characters that make it more readable. So on the left, this is just text, and on the right, we see the outputted format. So ** makes something bold, an underscore will make something italics. These dashes become bullet points when it gets rendered. These are headers of different levels, and you can see they actually are table of contents is generated from them. So this is built into Jupyter Notebooks and Google Colab as a way to be able to write something in a nice, neat way and present it along with your code, right? So I'm using it here, and as we do more work and do more analysis, we'll be writing our analysis in Markdown. And in this lab, I'm going to show you how to output Markdown from your code using f-strings and embedding variables in them. So I wrote some function examples, and I'll just briefly go through them. This is a very simple function. We always have def. We always have a function name. We always have parentheses, and the function header, the first line, always ends with a colon. After that, we indent, and that's the function body. So remember, a function is like a routine, a subroutine, a snippet, a block of reusable code that we want to call more than once. So if we're going to write the same code more than one time, it should go in a function. Like, simple as that. Write the function once, use it many times, right? So this is a very simple function. It can only do one thing. It always prints hello world. So the function def is the keyword that's part of Python. Say hello is the function name. That's what I gave it. I'm going to use lowercase letters and separate words with an underscore. If you need to use a number, you can, but it can't start with a number. And don't use any other characters in your functions, all right? And remember, we define the function once, and then we call it as many times as we need to. So let's just say I want to call it 4 times. I'm going to rerun this, and we can see the output down here. All right? So I wrote it once, called it 4 times. I get 4 hello worlds. All right. Now, to make functions more useful, we can make them more abstract with function parameters and with return statements. So once we have parameters and return, then they can become part of our program where we can capture the result into a variable, we can pass the result into another function, and we're going to be doing a lot of that today with our real-world examples. So this one calculates the perimeter of a square. It takes one argument, so the argument is the data we pass into it, and then it returns a calculation, right? So just one line within our function. Now Python has, and we'll move on. So Python has the idea of both positional arguments, where when you call them, you pass the data in the order that they're declared. That's kind of the normal, regular way to use function parameters. But they also have named parameters, and named parameters can have a default value. So you can call this function without passing in the tax rate that you want to use, and it'll calculate a 3% tax rate. So I give an example. We call it twice. First, let me just zoom back in a little bit. So first we calculate the tax on $100, and it's just going to use 3% because I didn't pass in a tax rate, right? But then I want to use my own tax rate, so I have two arguments. $200 is the price, and I want to use a 4.5% tax rate. And then my function will change tax rate to be 4.5 instead of, or 0.045 instead of 0.03. So these function parameters become variables, just like regular Python variables, that only live inside the function. We're going to take a look at a real world example. And this is a full function that I wrote that we're going to use in our program, right? So I call this function basemap. And basemap can be called with no parameters, with no arguments, which makes it easy to use. You just call basemap and you get a map back. But we can also pass in different arguments if we want to change the way it works, right? So the first argument you can pass is where do you want the map to be centered, right? And because I wanted to show you guys how to use an if statement, so if the default value is none, so if they don't pass anything in, the center becomes what I roughly estimated to be the center of the US, right? So we're going to center our map of the US. We're working with US data. So I put this in here. I could have done it this way, like that, but I chose not to because I wanted to show you this new feature of an if statement. But let me go through the parameters beforehand. We also have zoom, a map provider. This tells us which tiles to use, and then a name to give this layer on our map a name, which we aren't actually going to, we're not going to be using that any further today. All right, so we've already actually done similar things to if statements. When we do the filters and queries on our data sets, we write Boolean statements, so things that can be either true or false, like when we do is in or state equals tx. Those are called Boolean expressions, and they are a single or a combination of expressions that evaluate to either a true or false value, and then our program will do something with that true or false later on. So in its simplest form, we write if, and then we have a Boolean expression. So if the center is none, equals none, is not defined, then give it this default value, right? So if I didn't want to use named parameters, I would have to do it this way if I wanted a default value or to check. And then here I have another Boolean statement, but I have two clauses here. So I say if zoom is less than 1 or it's greater than 18, if it's outside of our range, just put it back to 5, to the default. Otherwise, we just leave zoom alone. So the way if statement works in Python, it starts with the keyword. So we have if, we also have else, we have elif, we'll get to them later on, colon, so this looks a lot like a function, and then we indent, one indent, and this is the optional text. It's only selected to run if this evaluates to be true. So this is a simple one. So center equals none. If center is none, it's true. If it's anything that's not none, so if there's any value, it's false. And this part of the code, line 17, never runs. Right? Same thing here. If either zoom is less than 1 or zoom is greater than 18, so only one of these two things needs to be true, then we assign the value 5 to the zoom variable, right? Okay. The next thing we do in here, we use folium to create a map. We pass in some data, so we're passing through the arguments that you passed into us when you called us. We save that map into a map called M, and we return it. So you're going to see, I'm going to use basemap as the map for all the maps I create in this project, and that's going to let us, if we need to, we can change the look of the map in one place by changing the basemap function, and it will change all of the maps we create once we reuse the code. So let me just call it up here on line 28, I'm using controlled / to toggle the comment here. And let's just run this. And we get the base map. And I'm looking at it. So this is the zoom. I actually, thanks to a tip, I fixed the attribution. I wasn't calling it correctly. I was passing the whole object, not the actual attribution in last week. So thank you for that. And I'm noticing I don't see Puerto Rico on here. So maybe we can move this up just a little bit and get Puerto Rico on there. I can change the zoom, or we'll just have to move to it because obviously we can't see Alaska or Hawaii either unless we zoom out or pan. But let's go down. Let's just change this to 34. All right. And see. All right, we have Puerto Rico here, but we're losing just a little bit of the northern continental U.S. So I can say 34.5. We'll leave it at this, and we'll work with that the rest of the day. No, I can't let it be. All right. So we'll stick with this as our base map. We can fiddle around with it later. But I want to show you how we can also use the center. So I'm going to comment that out. We only need to show one map here. Let's say we wanted to center and zoom the map on New Jersey. So the first thing I'm going to do, and this is review, but we're combining this in a much more complex way that we might see in a real program. So the first thing we do, we take our cities and we run this query, this filter, right? So that we only get the cities in New Jersey, right? So then we're going to get that geometry column. And from the geometry, we're going to get the Y coordinate and get the average Y for New Jersey. And then we do the same thing. And we get the average X for New Jersey. And those are our latitude, longitude. And when I first started working with maps, I was wondering why all the coordinates were in YX format when normally we do XY. But then I realized that when we talk about maps, we usually talk about latitude and longitude, not longitude and latitude. And that's why. So this is going to give us the center of New Jersey. And I can, let's just display NJ center. I'm not sure what we get when we do that. But we're going to take the center and we're going to say center our map there. And let's zoom it in more, like much more. So instead of the default 5, we're going to zoom it in at 12. Run that. All right. So that's what it calculated to be the center of New Jersey. And here's what it looks like on the map. We're more zoomed in and we've got New Jersey. As both an exercise in working with data and in Markdown, I created a data dictionary for the data we're going to be using this week. So a data dictionary is a document that describes your data, and it should provide the user or yourself information about where that data comes from, how it was gathered, when it came from, note any possible irregularities, tell us when data is missing and how missing data is handled, and so on. This is not a complete data dictionary in some ways because I don't describe the underlying ACS data, such as median income. Median income, there's some special codes for when it's missing that be negative numbers, and I'd have to go look at the census docs about what it is. But for every column in our data, for every field, I have a description of what's in that data. So this will just let you know. You can go back and see like what that data is like. And it tells us that like the population change is a change from 2017 to 2022. Things like that go into the data dictionary. And we'll just look in here and you see this very light markup. I've got some bolds. I've got some lists. I've got a level 2 header with these underscores, right? So that becomes this nice style text. And anything like this we call this a backtick when we're programming. Anything inside these backticks gets formatted like it's code, like it's computer code. So it's a fixed size font, and it gets a little highlighting around it. All right. So in the next section, we actually look at formatting with Markdown, right? Really, what you should do with the Markdown, you could click on this link, and that's Google's help document for using Markdown and Colab, and it tells you exactly how to use it. I read through it, and I'm just going to point out that when I make a numbered list, I do 1, 2, 3, 4, not 1, 1, 1, 1, and I use the dash for bullet lists instead of the star, because it distinguishes it from the star, which is also used for bold or for italics. All right. Now, eventually Markdown in Jupyter gets converted to HTML. It's just a easier to read syntax. HTML is a formatting language for the internet. And we are eventually going to both convert our Markdown to HTML and write some HTML code to make nicer maps and data visualization, because if our stuff's going to live on the web, eventually we're going to have to write some HTML to format it. But today I'm just going to use one tag, which is the bold tag, which will make text bold. But you can put HTML both in our maps and in our data tables to style the content. Now, finally, we're going to look at 3 color maps today. We have sequential color maps, right? We've got divergent color maps. We've got categorical color maps. And we are going to use this library called matplotlib. And let me just click on this and bring that up. What I want to show you, this gives examples of how to use it, but it also gives you the maps so you can see them. So a sequential color map is going to show a range like the purples. So it's going to go from light purple to dark purple, or like these red purples, they're going to take colors that are in the same family, but again, they're going from light to dark. And these are the names of them up here, and you can just copy them, or you can remember it and put it. They give you this gradient, and if we have continuous data, like the size of a city, for example, we can color code them in a range, and we're going to apply the entire range of our data so it falls somewhere in this gradient, right? And the first map I'm going to do is a sequential color map that's going to show, I think, income in cities. Now, divergent color maps have 2 scales, so a lot of times, like I'll use this cool warm one, like blue to red, or seismic, which is a darker blue to a darker red, or a red-green, and they show things that we want to show extremes at both ends of the scale. So instead of just going from light to dark, it's dark on one end and dark on the other. And I'm going to use a divergent color map to show the population loss or gain in our maps. So things in the middle are very lightly colored that are towards the center of the range of data, and then either end gets darker in the color range. Now these are categorical, qualitative color maps. So here the color itself doesn't have meaning except to distinguish that data point from other data points. In this case, like red isn't any more or less than brown, it's just different. So we use categorical maps to show different categories, and you can see a couple things around them, like accent and dark and tab 10. They have fewer different colors, and they're actually easier to distinguish. And then if we go to tab 20, there are 20 different colors, but when you're looking at it, it might be hard to tell, like this light purple from this light blue, from this light green, from this light gray, and so on. So it makes it a little bit harder to distinguish the data points, but if you have 20 different categories, you're going to need to do that. And if you have more than 20, they're just going to wrap around. So you're going to have 2 different things that are tagged with the same, like dark blue or light blue. All right, that's a quick overview of the color maps. And this link is in our document, and you can come here and grab the name and play around with the color maps when you're playing around with the code. So here's our first color map example. Let's actually look at the map first. Let me run the code. This is median income in the US by city in 2022. It's a sequential color map. Now the color map is called a color map not because it's a cartographic map, but because it maps a data point to a color, right? So the mapping is the connection, the translation between the quantitative data and an actual visual color, right? Not that it has to be on a map. We can use them in charts, pie charts, line charts, and so on. But we're using them here on a map So I see I didn't leave spaces here. I'll fix that when we look at the markdown part. But here's our map, and this is median income, and dark blue are the wealthiest areas, and light blue towards white are the poorest areas. So I look here, and I can see like California, Silicon Valley, definitely wealthy. We've got some wealth here in Chicago. Got some wealth around DC. And then if we want, we can zoom in and we can see we've got San Jose, and then Sunnyvale, Santa Clara, Fremont. So these are all where the big tech companies, Google, Facebook, so on, Apple, are all located out here. And they have created a lot of very wealthy people. So we have high median income in these areas. We can go look in San Francisco. This is the one that's killing me, that San Francisco is way out here in the Bay. But we can see, that they have more of a variety of median income, closer to the city, to Oakland and San Francisco. Zoom out, pan over, we can see Denver, right? And where the wealth is there. Same if we go to Chicago metro area, like are they actually in Chicago? So here's Chicago itself. We have some wealthier outlying cities. Now, if we see New York, we don't have that same pattern. And these are the things that we're talking about that we can understand when looking at spatial data, because we're only looking at cities. And none of the cities, like in Long Island, for example, are large enough to be in our data set. So they don't have 100,000 people in the city because they're more smaller towns. So there's a lot of wealth in this area. Obviously, it's one of the wealthiest places in the country, but they don't make it to the map. So New York City itself is not nearly as wealthy when you take the entire city. There's some very poor areas in the Bronx and Brooklyn, Upper Manhattan especially, South Queens, that get averaged into that median income. And then the cities to the north, like Yonkers, also, although Westchester County is quite wealthy, the cities aren't big enough to make it into our data set, or they're just towns, and because they're small towns near each other, right? So that's our first map. It is a sequential color map that goes from light blue to dark blue. So let's see how we made this map. First thing, we're going to create a scale for this map, right? So we need to know what is the low end of our scale. And we're going to take a single column, median income, in our cities data, and we're going to call the min function. So that just looks through that whole column and it gives us the smallest value. And then the same thing for the max to get the highest value. So this is the lower bound. This is the upper bound of our scale. Then we're going to decide what color map to use. And let's say we don't want to use blues, maybe because it conflicts, it makes it look like water. We could change it to purples. I'll run that. And we get the same thing, but in a purple scale rather than a blue scale. All right. So this is how we get a named color map from any of these names. And we could pick any of these sequential color maps that look good. It doesn't need to be just one color, but you can see they all go from light to dark. And just take the name and put it into that function, and we'll get that color map back. CMap is going to take a value between 0 and 1 and return something within this purple's map based on that value, where 0 is going to be the lightest and 1 is going to be the darkest. Next, we're going to create the norm function, which is our scaling function that's going to scale whatever numbers are within this range into a value between 0 and 1. So we're going to call normalize, and we're going to pass in, you see we're using these named arguments. The vmin is going to be the minimum income, and the vmax is going to be the maximum income, and that's going to return this normalizing function, right? Okay, so I don't want to make changes to cities itself, so I'm going to create a copy of it called data that I'm going to use to create my color column, to create my tooltip column, and things like that. All right, so I create a copy. Now, I create a function called getColor, and I'm going to apply that to the median income and create a new column called color. And when I create the map, I'm going to use this column as the style to color the points on the map. GetColor is actually fairly simple, but you see what we're doing here is we are wrapping a function within a function within a function. So we're making this nested function call, and they happen from the inside to the outside. So for every row in our cities data, so for all 340 cities or however many we have, we're going to look at the income for that row, and that's going to become this function variable, right? This parameter called income. And we take income, and first we pass it into norm. So let's say the median income was 132,000, right? So norm is going to scale that, and on our scale, that might come out as like a 0.7, right? Because it's higher than the average median income for our data set. So it's going to be closer to 1 than it is to 0. Then CMap is going to take that, and it's going to convert it to a color. Now, CMap returns colors in a format called RGB, red, green, blue, or RGBA, and alpha, which is the opacity of it, the transparency. But we need to work with folium, with Explore and geopandas. We need that to be a hex color, which you might have seen. They're written like hash, and then if we want, they go red, green, blue, like that. It's just a different format of representing it, and this is how HTML generally uses them, and that's why we need hex colors in our color function. So we call 3 functions all on one line using income as the starting data point. So first we normalize it from 0 to 1. Next, we color map it to get the color. Then we convert that color from RGB to hex. So that's all happening here on line 22, right? And a lot of code is being executed in this one line because it's bundled in these functions, right? So norm might have 10 lines of code. CMap might have, hundreds of lines of code if you include all the maps in it. And then, another dozen lines of code here. And they're all executed in one line because they're bundled up and reused by calling these functions. All right. So here on line 24, we apply getColor to every medium income in our data set, and we use the output of that as a new column called color. So if that was complicated, hopefully this is a little more straightforward. I'm creating a string. It's an F string, so it's multi-lines, and it can include variables, a triple quoted F string. And this is a level 1 header, so like a header 1 that I'm going to print out to the screen, right? Medium income in the United States, it basically creates this. The reason this is so weird is because Colab and my software that I'm using treat this $, Curly braces a little bit differently. Colab thinks that I want to format a function. So let's not go crazy with that for now. We'll just put USD at the end of it. Let's rerun this. All right. So the highest median income, the darkest blue, is going to be 174,506, and the lowest city has an income of only 19,000 as a median income. All right. So this is going to be our lightest purple. This is going to be our darkest purple. Right. So here's how this works. F says we can embed variables. We use curly braces to embed them. We created max income and min income up above by calling the min and max function. And then we put some markdown in here. This creates a header. These stars create bold. We can see it when it gets placed on the map. And then we call display. We can't just print this because it won't be formatted. So what we do is first we call the MD function that takes our title and it reads or it parses the markdown so it's formatted, and then display takes that markdown object and shows it as formatted text on our screen. All right. So this title string becomes this formatted title on our page, and we display it so that it goes above our map rather than below the map, and so on. Now this is definitely a review from last week. Remember that we can have custom tooltips, right? And that's what I'm going to do. I'm going to take the entire row in my apply, and for every row, I'm going to take the city. And I like this cleaner syntax. So row.city and row.medium ink, right? And make a small change. I'm just going to run it, make sure I didn't break anything before I move on to do anything else. The tooltips still look good, so I didn't break anything. We take this function, make tooltip, and then we apply it. And unlike apply here, where we do data medium ink dot apply, so this applies it only to a single value in our data frame, just one column, right? Always to medium income, and that's what gets passed in. When we apply it to the whole data frame, to data, it's going to pass the entire row for every row to our make tooltip function. That way we can take two different fields and combine them into the tooltip. So we create a new column called tooltip, and we use this function to combine the city and the medium income, right? And then I just threw a little bit of HTML. This is what HTML tags look like. They use angle brackets, the tag name, and then they can have some data inside of it. So if you look down here, we go up to Madison, Wisconsin. That's why that Madison is in bold, because I put those B's around it. That stands for bold, to make a bold element in HTML. All right, that's all. That's the only HTML tag I'm going to use today. The rest of it is just going to be plain text, but I thought I'd throw in a little to get us started. All right, the last thing, again, complete review from last week, but let's go over it the first time we use it here. We take our data and we call the explore function. So explore is going to create an interactive map. We're going to pass in a base map use as the M argument, right? So we call our base map function and we use that for M. And remember, M is going to choose the, not M, but base map is going to choose the tiles we want to use, the zoom and the center and things like that. So let me just run this again. So that's all coming from base map, right? And by the way, these tiles are the CartoDB positron tiles. So they have many fewer details and labels than than the default OpenStreetMap, which has, you know, Dwayne Reeds and pharmacies and bike parking. So it might be a better base model for our data projections because it's easier to look at the data without as much cluster. Even when we zoom in, like it's still going to show us some details and some street names, but they don't take over the view, and they're kind of subdued and in the background. So it lets us zoom in on our data and leave it there. All right. So that's the very first thing. The second thing, this is new. We're going to take this color attribute and we're going to pass in a series. So whatever colors we pass in need to match the order of the data that we're exploring. So if it's not a column in data, it needs to match it exactly. We can't reorder them or else our colors will be all messed up. Tooltip, we're going to say use this column, a single column for tooltip. So it's just a string that refers to the column name that we want to use for the tooltip. The tooltip keywords, this turns off the label, which I prefer. It would be nice if it were maybe the default behavior, but it's not. So when the labels are on, it says tooltip and then whatever value you want to show. So that would make sense if maybe we were passing, let me show you. If we wanted to do city, total pop, and median ink, if we wanted 3 columns and we just wanted to quickly create a tooltip that way, right? We would want to do it like that. We get this pop-up and we can show multiple things. But when we already have a nice tooltip, formatted tooltip, we'll just turn it off. And we don't need these square brackets because we're just passing a single value, tooltip, like that. All right, the last thing, you can change this if you want to. The style keywords are the styles for the points that we're plotting. And we're changing the size of them. Let's say we wanted them to be big. We can make it 10 pixels. And if we wanted them to be completely filled, like not transparent at all, solid, we can make that 1. Right? And there we have larger circles completely filled in, right? And you can't see the border until you highlight over it because we have this little highlight effect. All right, so this is our first color map. It's a sequential map that shows us the way that median income varies in the United States. I initially started with blues. We changed it to purples as the color. And the last thing I'm going to do is just update my text here to match the code, right? So a sequential color map on a Mac, darker purple indicates higher median income. Save that, run it. And I suggest at this point, you pause the video, you take a break, you play around with this code so you get a good sense of how it works, try different color maps, try some different styles for the opacity, change the tooltip. All those things are things you're going to want to learn how to do. And now's a good time to play around with it so that you're ready for the next examples and have a sense of how they work. We're using a divergent color map. And you can see we're looking at population loss and gain. So dark red, these are the cities that gain the most population. So we could think of this as like a heat map. They are hot. And dark blue are where we lost population. So if we scroll out, this gives us the best overview. And we can see that the cities gaining population are generally more interior California, in the south, and the ones losing population are along the coast. And if we scroll in a little more, we'll see these coastal cities have gotten very expensive. And you can kind of see like the affordability crisis, housing crisis being played out in the shifts in population here. So let's see how we create the divergent map. It's going to be very similar to the map we just created, but there are a couple new things here that I want to show you. First, we copy our data. Again, I'm reusing the data variable. We can do that. That's fine. So I'm not making any changes to city. I want to load that once. Like maybe it's a really big file. I don't want to waste the time to reload it every time. And if I need to, when I'm playing around with this code and exploring, if I need to make changes, I'm just changing them in data, and I can always just run this again and reset data to have my clean data, my fresh data, originally the one that I loaded. All right. So I'm going to change this. Now we call this practice refactoring. We make our code better without changing the way it works. Sorry about that. So we already copied the data, so we're just going to use data here and not use cities at all, right? So we make a copy of the data, and the first thing we're going to do is drop any rows that don't have population change. And this might have happened because I was using two different data sets, 2017 and 2022. If the census changed the geo ID for a location, or if they created a new location or deleted an old location in the way they manage data in those 5 years, we're not going to have that 5-year change. So we're going to have null data, and it's going to mess up our data. So what I chose to do, and remember this is always a choice, and they matter, I'm just not showing those cities at all. So if I wanted to maybe take some more time, maybe I would plot them in a totally different color and just have like a pop-up for them that explains why they're not here, why they are in our data set but not represented on this map. And I'd have to pull those cities out specifically. But instead, I'm just dropping them out of the data, right? So this is what we call a Boolean function, not NA, right? And it's going to tell us, oh, this is something in Colab, by the way. I might as well show you. Detect existing non-missing values, right? So NA, standing for not available, and it's a Boolean function that's going to return true or false. So it's going to look at every field for population change in data, and it's going to check to see if the value is missing, right? So it's telling us here, this is the documentation for it. It tells us exactly how it works. So if the value is NA, or it's none, like a null value, or a special numpy, NaN, not a number value, or if it's false, then it's going to return false. Otherwise, it'll return true. So we're using this as a filter. If this returns false, that row gets dropped, and we put that back into the same variable that we're using before. Okay, so to make this map, it's not really fair to use the raw numbers. Maybe a city of 100,000 people lost 10,000 people, and maybe a city of 8 million lost 10,000 people. They shouldn't be represented the same. So instead of using the raw population change, we're going to calculate a new field on data. And this is also a view called pop change percent. And that's going to be the number of people that changed divided by the total population, right? So this gives us a percent change, and I'm going to keep this percent. I'm not going to multiply it by 100. I'm just going to keep it as a real number in that range 0 to 1. So if nobody left, it'll be 0. If everyone left the city, it would be 1. And every other number is going to be somewhere in between there as a fraction, right? And oh, I just wanted to say that this is what we call vectorization in pandas. We don't even need to use apply to create this new column, because it's going to do it for every one of this column on the left side of the math operator, the division operator. It's going to divide it by every value in this column for the same row. We don't need to apply that or do anything special, right? So these are new from the last map we looked at. First, we're going to drop a couple rows so that we have a nice map. Then we're going to calculate a new field that we're going to use. This is the same. I renamed the variables to make more sense. So we get the minimum, and I'm calling it that is the maximum loss in a city is going to be our min value. And the maximum gain is going to be the max value in this new column we created, pop change percent. I choose a cool, warm color map. And if we go look at the Divergent color maps, we can see those are still sequential. Cool, warm is this blue kind of reddy orange color map. Seismic would also be a good one. And we can play around with it. Maybe I'll change it to seismic. Seismic. All right. We normalize those colors on the scale from the minimum to the maximum. Here we go on line 20. We create the function to get the colors. We use that function. We apply it to the value that's going to drive our colors, right? So we're mapping this value to a color in the seismic color map. We create this new color column. This is all the same as in the last one. We create a little markdown string that we're going to use as the title. We make a tooltip column that we want to be the tooltip. Again, we have the city in bold, and we're going to show both the population change as a percent and the actual number of people. And then we create that tooltip by using the apply. So we're taking this function we wrote, we're applying it to the entire row, and then we create our map. All right. And these are the same values we used last time. Let's run this with seismic. And voila. We have our map. Let's scroll down and see what's going on in Puerto Rico. Did I miss it? Yeah, I did. Here we go. All right. So we can move over Ponce, and we see there is a 9% loss, and it must be right around 100,000 people because they lost 9,000 people, right? Smaller loss in San Juan, and so on. So you can see the scale, right? And again, where are people moving? They're moving to the south. They're moving interior. They're moving to Texas. Moving to Phoenix, right? Now down here, I'm taking all the same data, but I'm filtering it so we only are going to get Las Vegas, right? And I'm going to use this data, the Vegas data, to create a new center for the map. But I'm not going to plot only Vegas. I'm going to plot all of the data, right? And here, we just, let's say I wanted a breakout map that just shows us Las Vegas and the surrounding areas, and I can see what's going on in Vegas. So here, we've got Paradise, which is our biggest loss of population, right? So it's actually a fairly substantial loss, and it looks like a lot of those people move down here to Enterprise, right? So this is more city center. I don't know Las Vegas that well, but people have been moving out of the center of the city into these outlying other cities, and I'm sure they're all part of the Vegas metro area. Like I think if you're from Spring Valley, you probably say you're from Las Vegas, and that makes sense. But this is just a zoomed in view, just showing you how to recenter the map, filter the data, get the center by calculating the average of the geometry. This would be if there were more than one city called Vegas. And then we can use that as a center. We pass it in, change the zoom, change the center when we call base map, and now we get another center. So again, why don't you pause the video, look at the map of the entire country, and then you might want to zoom into a different area and include that. Play around with the divergent scales a little bit and see which ones you like and why you think they make sense for visualizing this data, and so on. All right, the last map we're going to look at is a categorical color map, right? So here's our map, and this is a categorical map, and it shows the plurality of the ethnic, racial population for each of the cities in our data set, right? So it doesn't mean a majority, it just means that they're the largest single group within the data set, right? So red are cities that have a white plurality, blue have an Asian plurality, orange, black, African American, and green, Hispanic, Latinx, Chicanx, plurality, right? So let's look at Philadelphia, right? I didn't put any pop-ups or tooltips here, but we can just use our legend. See that Philly has more blacks, African Americans than any of the other ethnic groups, right? We scroll out, and this is what we want to think about when we're using this geographic data. What can we see about the US overall, just with this simple data we're looking at, right? So we see that black cities, black plurality cities, are concentrated here in the South. The white plurality cities are in the North and Midwest, but then also we notice that these wealthy areas also have a lot of white plurality cities, right? From we're looking at our wealth map. And then the Latinx population, a lot of the older big cities, right? The Northeast, along the border, along California, which, you know, is a big Chicano population. It was Mexico before it was the US, so it makes sense. Puerto Rico, we scroll out, we see that the fewer cities that are majority Asian Pacific Islander. We have Honolulu here, and then we've got cities in California. And Texas, right? But other than that, there are very few cities that have a plurality of Asians as their ethnic group. All right, let's see how we made this categorical map. Is there a couple new things that we did to make this map, including the legend, which for now I would say copy and paste the code and try and get it to work. I'm not going to go through everything, but I am going to explain a few new concepts here in this map. Okay, so for categorical data, one thing that we need to do is change the category to a sequential numeric value, and we're just using integers for our categorical data. Now remember, and these are the categories here, lines 8 through 17, right? So the numbers are not meaningful in the data. They're categorical, but 7 isn't more or less than 2. They're just different categories. So we need to be clear of that. And that's why we can't plot this using like a divergent or a sequential color map, because the numbers themselves don't have intrinsic meaning except that they're distinct from each other. Okay. So this is what we call a dictionary in Python. And a dictionary is a data structure, a data type that allows us to have keys and values. So I create a variable called ethnic cats for ethnic categories, and the keys are match the column names, and the values are the numbers I want to assign. So later on, we're going to look up a column name, and then we're going to get a numeric value for it using this dictionary, right? So a dictionary, think of maybe like a Spanish-English dictionary. You want to look up the Spanish and see the value in English, right? That's why it's called a dictionary. You look up the word and you get the definition, right? And this is a built-in data type that's just basic to the Python language, and we can declare it using curly braces. That means we're creating a new dictionary. Okay. So here's what we're going to do. First, we need to find out which category has the most in each city. So I guess let's just go way back up to the top. Scroll, scroll, scroll. And do we ever show the data? We do. So for every city, for Birmingham, Alabama, let me just show you some of these. I'm about to use it. We can do sample, which will give us, instead of always looking at all Alabama, sample will give us a random sample from our data set, right? So we can get 10 cities at random, and we can get a sense of them. So if we look at Boulder here, we can see the number of Asian, Black, Indian, Native, Latino, mixed, other Pacific Islanders, and white in Boulder, right? So these column names represent what the people marked on the census survey. All right, down, 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 down. Actually, I will use this. Go to our categorical map, and close the sidebar. All right. So these have to match exactly for this to work, the way we wrote this code. But first, we want to find out which category has the most for each city, for each row. And then we're going to convert that to a numerical value. Then we're going to take that number and assign it to a color category, right? So to make it clear, we're going to do it in 2 steps. First, we're going to create a new column called plurality. And we have a function for that. And then we're going to call getColor and put that into this color. Okay? So plurality is actually pretty short. We take our row, and we're going to call ID max on it. So we get the columns that we care about. You can see we don't have, here we list all of the census ethnic groups, but when I ran it, there were no cities that had a plurality that were outside of Asian, Black, Latino, or white. So to make it clear here, I'm only using those 4 categories because I already did some initial work with the data to see that they're the only ones that had a plurality. All right. So I take the rows I care about, and I call this ID or index max, right? So it's going to tell me the column name that has the largest number of this entire row, right? Of this series, right? So one row, a subselection of columns within it, and then I get, instead of getting the maximum number, I'm going to get the name of the maximum number. So that's going to be a string, and I'm just going to return that string, right? And that's going to be the plurality, and it's going to match one of these values, right? One of these values, actually, it has to, right? Okay, and I save that into plurality. And then I create my color map. I'm calling tab 10. We can go take a look at tab 10. Tab 10 is down here. And they go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if the category is number 8, we're going to get this yellowish greenish color. If it's number 0, we're going to get this kind of slate blue, right? Take a look. Let's change it up. We could go for dark or for set 1. Basically, I want to use the fewest number of colors that I can get away with that are distinctive of each other. I think I steered away from these because they have grays in them, And I didn't want any grays showing up in my data. It looks, these gray kind of implies that it's not active or there's no data for it, which is why I went with tab 10. And I'm going to stand by tab 10 for this data for now. All right, let's go back and see how we apply it. So first on line 32, we get the plurality as a string. And then down here on line 41, we convert that plurality to a color. And here we do it in a couple steps. First, we take the string name, the name of the plurality, and we find the category color. Basically do a lookup using our dictionary. We look up black, we get the category number 1, right? So we do that on line 29. Nope. We do that on line 38. And then we pass that value into our CMap, and we convert it to hex. Now, the big difference here between the other color maps we're using is that we don't normalize these values because they are not in a range. They are numbers, but they don't actually hold quantitative information. They hold qualitative information. So there's no need to normalize them. It doesn't make sense to normalize them. We're not scaling them. We're not doing anything like that. We're just giving them a number so that our CMap function can work to pick a number for that category. All right, we save it here. And just this is like how I knew that it was only black, white, Latino, and Asian by running this code. So once I calculate the pluralities, I can call unique on that column, and that'll return a list of the unique values, right? So even though they show up numerous times, I can just get the unique values, and here they are. So I use this F string to say that there were 4 unique pluralities in our data, and they are black, white, Latino, and Asian, right? Those are the values. Now here I'm using sample to show us what our data looks like. Just these columns, right? City, state, plurality, and color. So we can see we have hex colors, and they're going to be repeated. So anytime the plurality is white, we're going to get D62728, D6728, right? Because that's the color for this category, white. Okay. So now I'm going to take this dictionary and convert it to a data frame. And then I'm going to create a styled table with that so that this is a data frame that basically has 1, 2, 3, 4 columns and then 1 row. And each row has 1 value, which is the color. And I'm styling it so that we can actually see the colors, right? So that's what's going on here. You're not responsible for knowing this right now, but you can take a look. It's another use of data frames and dictionaries and showing how they can work together, right? So later on, we're going to look at doing more styled, our own personal legends. But for now, so we have a legend, we're just running it here. And here's what it looks like. And I created it and I put it into a variable called legend so that I can use it again. Here I create my title. I display the title. I display the legend. And then I display the actual map, right? So I use the base map. I use the color column. I say tooltip none, although let's be honest, it would be nice to know the city. I put none because I was going to have you guys do a tooltip or a pop-up for this one. The radius is 5, the fill opacity is 8, the same values I've been using the whole time. And there you go. Our categorical color map. All right. So that ends the video for Lab 4. In this video, we did a lot of review of working with data frames, especially using the apply function. We used functions in real-world ways. We learned how to style text with Markdown, and especially we learned how to use color maps to display quantitative data. All right. I look forward to seeing the work that you do using color maps to explore this data set. As always, any questions, let us know.